Hello, San Sinukub. Good afternoon. I have a very short video for you this afternoon as you prepare for FA3 tomorrow. So, the FA3 includes lemniscate, cardioid, and the entire chapter 4. So, in this video, we'll have a review on topics 4 and 5. So topic 4 is all about the three-dimensional coordinate system. So it's just understanding, looking at the parts of the Euclidean space and plotting of points. And topic number 5 is on computing distance between 2 points, finding midpoint of a segment in the Euclidean space, and the determination of equation in general and standard forms of a sphere. So let's start right away. Let's get to know the parts of the three-dimensional system. So the 3D space consists of three mutually perpendicular axes, the x, the y, and the z axis. So in this illustration, this line here is the x-axis, y-axis, and the z-axis. So this direction is positive x, so the opposite side is negative x. This direction here is positive y, and to the opposite side, negative y. Going up is positive z, going down is the negative z-axis. The three-dimensional coordinate system is also called the 3D coordinate system or Euclidean space, denoted by RQ. Now, in the 2D space, we have the xy plane. The x and the y axis form the xy plane. So in 3D space, this x and y axis here form the xy plane. So in this case, z is 0. That's actually here. Xy plane is the case when z is 0. While the y and the z axis form the yz plane, in this case x is 0. And lastly, the x and the z axis form the xz plane, where our y is 0. So these planes intersect at the origin and divide the space into 8 regions called the octants. Into this space, we call the regions formed by the x and y axis as quadrants. So in this case, we call it octants. Now, let's see what's on the next slide. Okay, plotting of points. So on plotting of points, the x coordinate of the point is the directed distance from the yz plane. So this is the distance from the point going to the zy plane or the yz plane, while the y coordinate is the directed distance from the point going to the xy plane. And lastly, the z coordinate is the directed distance from xy plane. So here, our third coordinate, this one, z. It's the distance from the point going to the, sorry for my writing, distance from the point going to the xy plane. So let me use red. Sorry. Point going to the xy plane. Okay, so let us now plot points. First, let us plot the point -5. So this is our x, -4, and 0. So this is my x axis. The x coordinate is 5, so it's referring to this point here. Let me use blue instead. 5. Sorry. 5. Then the y coordinate This is the y-axis is negative 4. Negative 4 is here. So I will duplicate a y-axis here from 5. And the distance or that line segment is negative 4. So this is the point on the xy plane where negative 5 and negative 4 meet. So since z is 0, this is already the point negative 5, negative 4, 0. Now, number 2, plot the point negative 5, negative 4, but this time your z is 2. Same x, same y, but this time our z is 2. So meaning, what I will do is I will duplicate a z-axis. No, I will duplicate a z-axis here, considering this point as the origin. So I'll draw a vertical line here. So that will be a duplicate of the z-axis, but the origin now is at negative 5, negative 4, 0. So let me do that. I will draw the duplicate. Oh, of course, it should be parallel with respect to the z-axis. Okay. So note that if I will look at the z-axis from the origin, this is my 2. Right? So if I will look at this as my z-axis from this point, the origin, my 2 will be, where will that be? So same length, right? From here. So somewhere here is the point negative 5, 4, but the z coordinate is 2. So I have a distance from this plane going up 2 units. So that's it. Let's now look at another point. Plot the point 6, negative 3, negative 4. This is my x, my y, and my z. So x is 6. So this is 1, 2, 3, 4, 5, 6. Negative 3, y is negative 3. So 1, 2, 3. So 6 and negative 3 intersect on the plane x, y plane at this point. So kanila nga point, this point only, this is 6, negative 3, 0. Right? I do not have a distance going up or perpendicular with respect to xy plane. So, if I want to plot 6, negative 3, negative 4, then I need to create a duplicate of the z-axis. So, let me do that. Going down. Where is 4? If this is my original z-axis. So, this length here is negative 4. So, I'll just duplicate that length here. Okay? I'll duplicate that length here. I think that's the same na. So, this point here is the 6, negative 3. 6, negative 3. And the z coordinate is negative 4. So, that's it. Okay. I'll make another video for topic number 5. So, this is the end of topic number 3.